6.1 and 6.2 are about what's called the law of sines and law of cosines. And what we use the law of sines and law of cosines for is to solve triangles. Because remember from maybe geometry or definitely algebra 2 that when we solve a triangle, we need to find all three sides and angles. And we would usually do that with SOHCAHTOA, sine, cosine, and tangent, but that only works for right triangles. So if we don't have a right triangle, they're called oblique triangles, we can't use SOHCAHTOA because there's no h, there's no hypotenuse. So that's why we use the law of sines and law of cosines. Now, to solve these triangles, we need at least one side and two other pieces of information. So those two other pieces could be another side or two. Like we could have all three sides and then be able to calculate the three remaining angles. Or we could have one side and two angles and be able to figure it out. Or we could have one side and two angles. So like I said, we need at least one side though, because the angles just tell you the rotation. They tell you nothing about how big a side is. If you think about equilateral triangles, all the angles in an equilateral are 60 degrees, but we could have all three sides be 5 inches long, or we could have all three sides be 12 inches long. So knowing all three angles is not enough. We need to know at least one side. Now, through today's and tomorrow's information, there's a couple things that we need to recall. First is that all angles in a triangle add to 180. I think we know that. I think we're good at remembering that. The second piece of information is something that maybe you didn't talk a lot about in geometry, is that the shortest side or the smallest side is across from the smallest angle or opposite, and that the largest side is across from the biggest angle or opposite from the biggest angle. So essentially what that means is that your biggest side does not touch the biggest angle, and the shortest side does not touch the smallest angle. And that the sum of any two sides must be greater than the third side. So we can't have, 5, 11, and 29. We can't have a triangle with those lengths because these two sides don't add up to a number greater than 29. And then the last part of information, and we talked about this when we were doing trig stuff, that you can't take the inverse trig function of a number bigger than 1 or smaller than -1. That just means that the angle doesn't exist or the triangle doesn't exist. So for all of these problems, we're going to have a triangle and labeled with capital letters for the angles and lowercase letters for the sides. Now, we always go with the opposite or across from the angle. So here's angle A right here. So side A would be across from it or doesn't touch angle A. Side B does not touch angle B, and side C does not touch angle C. They're across from each other. So that will just make things a little bit easier to organize. Now, the law of sines, we use the law of sines when we have two angles in a side, whether that side is included or not included. Included means in between. So from geometry, we know we prove triangles by angle, side, angle, and angle, angle, side. And if we have those situations where we're given two angles and a side, we're going to use the law of sines. Now, if we have two sides and the non-included angle, which is the angle in between the two sides, there could still be a triangle, but we call that the ambiguous case. because there could be a situation where there's two triangles when we have that situation. And then for law of cosines, we use law of cosines when we have all three sides, or if we have two sides and the angle between those two sides. So like in our picture here, if we knew what side A and side B were and what angle C measure was, then we could use law of cosines. So let's first talk about the law of sines. The law of sines, I think, is the easier one because it's just an extended ratio. So it is the sine of A over side A is equal to sine of B over side B, which is equal to the sine of angle C over side C. And we only use two of those at a time. Or we could also do the reciprocal, or A over sine of angle A equals B over sine of angle B equals C over sine of angle C. There's really no difference between them. You just want to make sure you're consistent. Either put the angles on top of all your fractions or put the angles on the bottom of all fractions. I tend to put them on the top. That way it's easier for me to organize. There's really no difference in how you would solve the problem, because if we have two fractions that are equal to each other, we would cross multiply those. Law of cosines is a little bit more involved because you have options. So law of cosines looks a little bit like the Pythagorean theorem, where a squared, remember lowercase a is the side length, is equal to b squared plus c squared minus 2 times ab times the cosine of angle A. So that means we would have to know what sides B and C are and what angle A is to use that. It can also be written in this form. B squared equals a squared plus c squared minus 2ac times the cosine of B. And then it could be written as c squared equals a squared plus b squared minus 2ab times the cosine of C. So the side that we're trying to find has to correspond with the angle we already have. So you notice if we're trying to find side A, we know what angle A is. If we're trying to find side B, it's going to be cosine of angle B. If we're trying to find side C, it's the cosine of angle C. So once you do the law of cosines, though, you have to now look at this information that I have on either side of it to understand where you're going to go next. If you have three sides, you want to find the largest angle first. And the reason that you want to find the largest angle first is that it will eliminate the possibility of extra triangles if there aren't any. And then after you find the largest angle, you can either use law of cosines to find the remaining angles or use law of sines. I like to use the law of sines instead of cosines because it's easier for me to do cross multiplying two fractions than this whole mess here with x with second powers. Now, if you're solving a triangle that has two sides and the included angle, you have to find the missing side first. After you find the missing side, you have all three sides and you can make two choices. One is use the law of cosines again to find the largest angle, or the next largest if you already were given the largest one, or use law of sines, but you must find the smallest angle next. And this will make more sense when we do examples. We say, well, how do I know it's the smallest angle? Well, it goes back to up here. The shortest side is across from the smallest angle. So that's how you can make sure you're finding the smallest angle next. And the reason you want to do that is because when you take the inverse sine, because sine is positive in quadrants 1 and 2, when you take the inverse sine, you could get 30 degrees or you could get 150 degrees, and one of those may not make sense given your triangle. So I know that's a lot of information, and it is confusing, but once we see these examples and talk through them, I think it's going to make a lot more sense. So it says solve the triangle, which again means find all missing information, round to the hundredths when needed. So your first step will always be drawing triangle ABC. It doesn't matter how you draw triangle ABC, because I know some people, you may draw this and you say, oh, how do you know angle A is only that big? How do you know it's not? How do you know it's not like this, where angle A is, an obtuse angle? It doesn't matter. It's just for us to organize our information. And I think we can agree that this does not look like a 10-degree angle, but we're just organizing things. Oops, I'm sorry. Side A is 4.5. And angle B is 60 degrees. So from here, we need to find what angle C is. We need to find out what side C is, and we're trying to find out what side B is. I'm going to find side B first. So I'm going to use the law of sines. The sine of 10 degrees over side A, which is 4.5, is equal to the sine of 60 degrees over B. We don't know what B is, so we're going to leave that variable there. So anytime we have a fraction equal a fraction, we cross multiply. So we have B times the sine of 10 degrees equals 4.5 times the sine of 60 degrees. Now, I only want to type this into the calculator once. So before I get that out, we'll divide both sides by the sine of 10 degrees, which cancels. So B is equal to, and I'm going to type that all into the calculator at once. We do need to be mindful of parentheses since we are dividing. So 4.5 times the sine of 60 degrees, close your parentheses, divided by sine of 10 degrees. Now I'm going to double check my mode. I'm probably in radian mode. Yep. We want to make sure we're in degree mode. Hit enter and we get 22.44. So now angle C, we know that all the angles in a triangle have to add to 180 degrees. So 180 minus 10 minus 60 equals 110 degrees. So that's equal to 110 degrees. Now we're going to do the exact same process. And I want to use sine 10 over 4.5. I could use sine of 60 over our calculated B value, but if I made a mistake with that, I don't want to use wrong information to calculate the wrong side. So sine of 10 over 4.5 equals sine of 110 degrees over C. And we can cross multiply, and you probably picked up on this already, but we can just write this cross multiplying and dividing all in one step. So we have 4.5 times the sine of 110 degrees, and we know we'll have to divide by the sine of 10 degrees, and that will equal C. So in the calculator, 4.5 times the sine of 110 divided by sine of 10, and we get 24.35. So then we want to just write down our information here. Angle C was 110 degrees, side C was 24.35, and side B was 22.44. Now I like to go and make sure that this triangle makes sense. All the angles add up to 180 degrees. The smallest side, which is 4.5, doesn't touch the smallest angle, that's 10 degrees. And the largest angle, which is 110 degrees, does not touch the largest side, which is 24.35. So this triangle makes sense. All right, now, number 2, and we're going to draw a triangle. A, B, C. Angle A is 50 degrees. Side B is 15, and side C is 30. So we have side A that we don't know. So this is a situation where we have two sides and the included angle. This is SAS, which means we have to use law of cosines. SAS right here. So that means that A squared is equal to the other two sides, 30 squared plus 15 squared, minus 2 times 30 times 15 times the cosine of 50 degrees. Now we can throw this whole thing into the calculator as long as we are careful with our parentheses. So now in the calculator, we have 30 squared plus 15 squared minus 2 times 30 times 15 times the cosine of 50 degrees. And that gives us 546.49. So A squared equals 546.49. And then we square root both sides. So the square root of 546.49, and we get 23.377 or 38. 23.38. Okay, so now we have all three sides. Now we have to find an angle. And like I said, we want to find the smallest angle first. And again, the reason for that is when we take the inverse sine, we can only get acute angles because the inverse sine is going to give us an angle in quadrants 1 and quadrants 4, positive or negative angle. So we don't want to find the largest angle because what if it's an obtuse angle? We won't be able to know for certain. So let's find the smallest angle. Because at the smallest angle can't be obtuse because then there'd be two angles that are bigger than 90, meaning the sum of the angles would be bigger than 180. So we're going to find angle B next. So the sine of 50 degrees over 23.38 is equal to, we don't know what the sine of B is, or we don't know what angle B is. It's going to be over 15. So again, we're going to cross multiply 15 times the sine of 50 degrees divided by 23.38 is going to be the sine of B. So again, we're going to type that into our calculator all in one step. So 15 times the sine of 50 divided by 23.38 So we get 0.49147 and so on. We're going to use 4 decimals because that will give us a more accurate angle. So 0.4915 equals the sine of B. Then the inverse sine of 0.4915. So in our calculator, second sine 0.4915. And we get 29.439 or 29.44 degrees. So now that we have 2 angles, we can calculate the third one. 180 minus 50 minus 29.44. And that is equal to 100.56. So that would be what angle C is. So angle B was 29.44 degrees. Angle C was 100.56 degrees. And then side A was 23.38. And again, we verified the smallest side is 15 degrees as angle B, the smallest side is 15, and the smallest angle is angle B at 29.44 degrees. The biggest side is side C, and then angle C is the biggest angle, so the triangle is good to go. All right, so I'm going to do example 4 next, and I'm going to have you try the other 3. Because example 4, we know just all 3 sides. A, B, C. And we know that this is 31, this is 52, and this is 28. This is an SSS. We know all 3 sides here. So we want to, we have to use the law of cosines for this one. And we're going to find out the largest angle first. The reason for that is if we find the largest angle, that we can switch to law of sines afterwards to find the other information. If we find one of the smaller angles first, well, when we switch to law of sines, that could create a situation where the angle we're finding could not be the correct angle because we have to account for the angle being obtuse. But if we find the largest angle, that will tell us if the other angles are going to be acute or obtuse. So we're going to do 52 squared equals the other 2 sides squared, 31, minus 28 times 31 times the cosine of B. Now, we can't type all this in the calculator because we don't know what B is, but we can type in this part into the calculator, and 52 squared. So 52 squared is 2,704, and 28 squared plus 31 squared is 1,748 minus, this should be 2 times the 2 sides. So 2 times 28 times 31 is 1,736 times the cosine of B. So now we have to solve this. Now, for whatever reason, people will like to subtract these 2. You can't do that because over here, this is being multiplied by the cosine of B. Like, you guys wouldn't do 1,745 minus 1,736x. You wouldn't combine those. You know you can't because they're not like terms. So don't do that in this problem. So we're going to subtract 1,745 from both sides. So when I do that in the calculator, I get 959 equals negative 1,736 times the cosine of b. Divide both sides by negative 1,736. We get negative 0.5524. So negative 0.5524 equals the cosine of b. So then we have to do the inverse cosine of negative 0.5524. Oops. And we get 123.53 degrees. So now we have one angle, and we can use that to find the others. And that one angle we found was bigger than 90 degrees. So that means none of the other angles can be bigger than 90, which allows us to use the law of sines without issue. So now I'm going to label that in here. So it's going to be the sine of 123.53 over 52 equals, we're going to find the smallest angle next, so sine of c over 28. And again, we know it's the smallest angle because it's across or doesn't touch the smallest side. So then we'll cross multiply and divide. So 28 times the sine of 123.53 over 50, over 52 equals the sine of c. This gives me 0.4489. So then we do the inverse sine of that. And we get 26.67 degrees. So now that we have two angles, we can do 180 minus 123.53 minus 26.67. And that gives us 29.8 degrees. So our information that we calculated, angle A was 29.8 degrees, angle B was 123.53 degrees, and angle C was 26.67 degrees. That's what we were trying to figure out. All right, so like I said, I want you to pause the video and try these other three problems, please. And then once you're done, you can unpause it to see if we got the same answers. All right, so let's look at these now. I know that these problems take some time because of all the steps that you have to do for calculating, but it does get a little bit easier, again, the more that you do them and the more shortcuts that you can take, because I know sometimes when you're finding angles, instead of getting a decimal, you could just type in the entire fraction. Like down here, like you could just do the inverse sine of that fraction to get your angle right away instead of getting that decimal step. But okay, so here are the answers here. You're always finding three pieces of information. You're always given three pieces of information, and then you have to figure out which method to use. So that's number 3. And then here's numbers 5 and 6. So you can see your answers for that one. 5 and 6 were very similar. You had to start off using law of cosines, And then I decided to switch to law of sines after the words, and then found the smallest angle after that, because then you get two angles and you can just do 180 minus the other two angles to get the last one. So in all these problems, at one point, you could do 180 minus two angles to give you the third angle. So that's it for the law of sines and law of cosines. Thanks for watching. Make sure to like and subscribe.